Hello everyone, this is our next video of PCNSA series. In this video, we are going to discuss identify and implement proper NAT policy. Today topic is a source NAT. So let's start with the source NAT. Source NAT is a typically used by internal users to access the internet. The source address is translated and kept it private. So generally in our offices or home, we use the private IP ranges. And to access the internet, we need a public IP address. So we translate our private IP address to the public IP. This we called as a source net so that users can access internet. And in the Palo Alto firewall, we have three types of source net. So first is the dynamic IP and port. Allow multiple hosts to have their source IP address translated to the same public IP address with different port numbers. The dynamic translation to the next available address NAT address pool when with you configured as a translated address pool as IP address range of a subnet or combination of this. So it means that dynamic IP and port DIPP which allows you to allow multiple users or computer. Let's say you have a 192.168 1.0/24 and you want to access this all users can access to the internet, so you have to configure PAT so that all this range can be translated to your one public IP address and internet will be accessible for all users. So DIP we call as a PAT because the Palo Alto firewall will take or use multiple port numbers for the translation of the private IP to the public IP address. So in this process, the firewall will choose the port number for the translation. And the second translation is a dynamic IP. So dynamic allows you one-to-one dynamic translation of source address, no port number. So in this process, let's say you have a 192.168 1.0, it's your LAN subnet /24. So you need a /24 of the public range also, so that once the any users come and go for the internet, any available IP on this pool will be available. So let's discuss here. We have to select any public ranges. For this example, let's say I am taking as a 101, 101, 25, 30. So these seems to be a public ranges /24. So if you have a large number of public IP address and this is required by your organization, then you can do the netting in this way also, where you need a same block of subnet so that users want to access internet, they will pick any available IP on this pool for the internet process. If you don't have a much IP address in the public ranges, then upcoming new connections will be dropped. So this is related to the dynamic IP. Source address pool is a larger than NAT address pool, and eventually NAT addresses are allocated. New connections that need address translations are dropped. So as I told you, so once you have allocated full public IP addresses available on your pool, so the new connections one reaches to the firewall, that connection will drop because of no further public IP is available for the translation. So, and the third is a static net. Here we will do one-to-one netting. Let's say we have a 192.168 1.10. Then similarly we can do with 202.53.7.53 on kind of that any public range. So in this case we will do one-to-one netting. So only this IP can access to the internet. So this is the net source net available on the Palo Alto. First one is a dynamic DIPP. So this is where source machines have the when the source machine will generate a traffic, reach to the firewall. Firewall use different port numbers, and all traffic will go to one public IP address, and they will map with with respectively port numbers. In the second case, dynamic IP, once the traffic comes to the firewall, you have a bunch of public IP addresses. Any available IP will available on the Palo Alto firewall in the pool that will use and process the traffic. If you don't have available public IP in your pool, then upcoming new connection will drop. In the source NAT static, this is the one-to-one NATIC. Your LAN, let's say you have a one LAN PC 192.168.1.10. Then you need a one public IP address. Only one IP can access to the internet. So I have deployed my lab on this. So let's quickly go through it also. So in this lab, what I have did, this is the my Palo Alto firewall management interface is connected towards the net, and this net is for the my wireless, so that I can access this Palo Alto on my web browser. And this Ethernet 1 by 1, I have assigned the external 3.1 IP address, and this switch I have added as a L2. This is the internet switch I named as an internet switch, and this is the public server where I have assigned on this first Ethernet 0/0, the IP address is 3.10. I have assigned one loopback address 5.5.5 so that I can generate traffic from my LAN to access this loopback. So I can show you the further configuration also. So start with the external server. In this server, I have only assigned the IP address and that static routes towards this LAN subnet. I have added one static route towards this 172.61.0 subnet, and further this interface I have assigned 3.10 and a loopback address 5.5.5. Let's validate the configuration. So IP interface brief. So if I show you the IP address, so I just assign the 3.10, and which I have mentioned here 3.10 on F0/0. So I have a one loopback address also, which is this loopback 10, so that I can generate you traffic for other IP address or other ranges. And we have one static route also, so that this is a static route for the reverse route. Return traffic once that reaches the external server, and it again comes back, respond to the internal switch. So this is for the that static route. So this is all related to this external server. I have enabled telnet to access this router from my LAN switch, so that I can show you the net part here. And we have a Palo Alto that I will show you, and for that host level, I did not. I have only assigned the IP address and one default route towards the Palo Alto firewall. So if you see, so I have assigned 1.10 on this fast Ethernet 0/0. This is fast Ethernet 0/0. So that this router can work as a client in my lab scenario. So this is the IP address, and I have added one route so that all traffic can be forwarded to the Palo Alto IP route. So I'm using just filter to show you the route. So I have added one default route towards this firewall LAN interface. So this was related to this internal we called as an internal client or internal PC, and this is our external server. Let's come to the Palo Alto so that I can show you the Palo Alto configuration as well, what I have did for Palo Alto. Till the time it is coming up, let's validate the other configuration. So in an internal switch, I did not have any configuration. It's purely L2 connectivity. And here internet switch, it's a purely L2 connectivity. And this on the firewall Ethernet 1/1, I have assigned 3.1. In the firewall Ethernet 1/2, I have assigned 1.1. That will act as our trust network, so that our internal PCs can be connected here. And this is our internet switch. So our ISP line is connected to this Ethernet 3.1, and this will be the basically our untrust zone. This will be basically our untrust zone. So let's the firewalls come up. So we'll discuss on that what changes required from the Palo Alto also. And I will also show you the configuration which I did to complete this source net. So let's start with the network configuration. So what I did on the interface level, and interface level, I just assigned the IP address and the zone and the virtual router. So once it's come up, we'll show you. So first I show for Ethernet 1/1. Here I have assigned virtual router as a default, security zone as a untrust, interface type is a layer 3, and second I have assigned this IP address 3.1, so that this can work as a outside. So assigning the IP address is very simple. You just need to click here and type the IP address, it will take it. Assigning zone, you need to select here untrust. I have created already one zone, so I'm using that. And virtual router, I am using the default. So same process I have applied for Ethernet 1/2. Here I have assigned the IP address is 172.16.1, and the security zone is a trust zone. I can show you the configuration as well. So virtual router is a default, security zone is a trust, and this is a IP address. So I have added one default routes that points our ISP side, so that any traffic which we don't have any route will forward to that route. So I have added one default route here, so that any traffic which is not belongs to this Palo Alto firewall will send to this internet switch, and it's come to here, that 3.10. So one default route is here and static route is there. So, and the purpose of because this route and this is the default route is required for any ISP, so that they can go to the internet. So for the adding that default route, go to this static route, click on this. I have to add this node, you need to click here. So I have already added. So let's review that. So here I have typed the default route name. This is the destination. This is the default route 000/0. And here I have selected Ethernet 1/1. So 1/1 is the basically this interface. This 1/1 is this interface, this outside interface of the Palo Alto firewall. And here I have selected 3.10. So this is the 3.10. So that any traffic which comes by this Palo Alto firewall reach to this external server. So this routing is completed. Now on the policy side, so two policies is required. First is for the security policy to allow the traffic. Second is to NAT policy so that I can translate my this 172 network to this 192.168 network. So my source address will get translated. So let me show you the policy. Here the name is allow external server, and in the source zone I have selected trust because this is the trust zone, and I have created one object. This is the internal LAN object. which which is having 172 network. In the destination zone is interest, so this one is interest zone, that internet zone. I keep destination as any. I have selected one application as a telnet because I am only testing for telnet applications. So better idea to add the telnet application. It creates a more granular control of the applications level. On the port level, this is the 23 service port which is used by the telnet. So I have created one service port and applied to this destination, this port numbers, 23 port number. Action, this action is allow and log at start session and OK. So this is the security policy basically required to allow the traffic. In the real environment also we require the granular level of control. So it's better to go with that. So at this time, we have not seen any hit count on these policies. This is 0. I can refresh that also. If I refresh here, so it is 0. On the NAT policy, I have configured the DIPP, dynamic address with port number. So in the source NAT lab, I have typed the name. What will be the name? In the original packet, source zone will be the trust because traffic is coming from trust. Source address is the internal LAN. Basically, this is our LAN networks. On the translated packets, I have selected type as a dynamic IP and port. So I am using the interface address. This Ethernet one, and the IP is 3.1 on the interface. It's automatically selected. So this configuration is I have completed. So that video keep short and I will cover multiple topic. So I can access my LAN PC, and this is my external server also, which we don't need. But to demonstrate the lab, I can do that. If you see the external server host name is this external server, and the LAN site which we have on, this is our LAN site, and this is our Palo Alto VM I have taken on the SSH session, so that I can show you some outputs from session to clarify the other things and policy uses also. So I will try to initiate connection from internal PC towards the external server. So I am creating the session. So I have to type my user ID. Now I jump to the external server. So if I go on the external server, who who is currently logging on this router, so we'll show that detail also, who is logging. So if you see, I am accessing with this 3.1. So 3.1 is basically our firewall outside IP address. So I am accessing 172, and that translated to this 3 network 3.1, and using that I am accessing this router. So this indicates that our source NAT is working fine. So I'm able to access the server. If I say exit, so this is connected. If I say again telnet, then it will, I have to type this ID password and it is entered. So now first to verify that our policy it got hitted or not, let's check with the NAT. So at this time it is 0. Now let's refresh it, so that we can say that if we have a hit count or not. Same as with the policy, let's go with the security policy. So hit count indicates that the usage of the particular policies which we have. So it is not refresh it. Let me refresh it. So this we use for the source address translations. So yeah, now this hit come. So because of the VM and lab, sometimes it takes a delay. So we have now the logs for the last IP, the last hit and first hit. So this indicates the timings. what are the policy uses, and hit counts, what how many hit count is having, what is the application seen, as I told you that telnet is seeing that, and this is the usage of also. If I go to the net also, we will see the hit of net policies also. So this and this is not still showing here. So let's refresh again. It takes a time. Till that time I can show you the other thing also. If I go to the source session all, so I have to exit it. I was on the configuration mode. Source session all. So it will show the whatever session is running. So we have a one session. It is the application is telnet. Application is telnet. State is active. Flow is a type is a flow. Flag is a NS NAT source. And it stands for NAT source. So they have also discussed. Let's open this session in a very detailed way. So for that, source session ID, I have to type the ID also. That's 71. So it will show the detailed way of this source net. So what is saying that client to server means C2S means client to server. The source is a 1.10, which is our real IP address, and the destination is 5.5. We hit this, and the destination port is a 23, and flow is a type is a flow, and client to server. This is the server to client flow, where source is a 5.5 means server is responding. And the destination is a 3.1. Basically, this is our netted destination, and that destination port is a 54646, and the source port is a 23 because server responding on 23. Here are the policy uses. If you see, this is the firewall policy rule name, which is using to allow this connection, and this is our NAT rule, which we created, source NAT lab rule, to perform that source NAT. So this using this session ID, you can find out the very detailed way of the particular session. So this end reason is unknown because this sessions is currently running. And there are other applications. If you see, the application is also showing the telnet, which is correct. And other filters, other options, or if you have using the security profiles and other thing, that is also well. And this is, if you see, this is the ingress interface, and this is the egress interface, traffic in and traffic out. So all the information here is available, which confirms that our source NAT is working fine. And now we will see the NAT usage also. This is our NAT usage, and this is the hit count. So this is related to that DIPP. If you want to change the other destination types, you can change with here. I'm using DIPP. You can use the dynamic IP. Here you can provide the ranges of the dynamic IP. Further, you can use the static also. It is like if you require the static communications, so that you can do the static also. So based on the requirement, you can use the different types of the source net. But in generally, for the source net, we have seen that only DIP is mostly used until and unless if they are any requirement to create the other type also. For the static, we need the translation address. So this video is related to the source net, which we covered. In the next video, I will cover the destination net. Stay connected this us. Thank you so much for watching this video. Please share this video with your friends and like this video, and you can subscribe Firewall Expert for future upcoming videos. Thank you so much.